Welcome to qnawire.
We're going to answer the next four following questions regarding colligative properties. So, first thing first, we need to identify the number I corresponding to each of the compounds. In this case, the first compound is going to have the non-electrolyte, which will have a value of I equal to 1. Over here, we're going to have HNO3, which is going to have a value of I equal to 2, since it is going to dissociate into H plus NO3 minus. Over here of the barium hydroxide, we're going to have a value of I equal to 3. And finally, for the potassium phosphate, we're going to have a value of I equal to 4. Next up, we want to know what is going to be the freezing point of the solution in degrees Celsius when 55 grams of water is mixed with 13 grams of electrolyte sodium nitrate. For this compound, the value of I is going to be equal to 2. So the change of the freezing point is going to be equal to minus 2 times the freezing constant for water times the molality of the solution. This is going to be the freezing point depression. The value for Kf in the case of water is going to be equal to 1.86. So the only information that we are missing is going to be the molality of the solution. This is 1.86 degrees Celsius divided by molality units. So the molality of this solution is going to be equal to 13 grams, oops, sorry about that, 13 grams of sodium nitrate divided by 85 grams per mole, which gives us the amount of mole of sodium nitrate, which is going to be contained in 55 grams of water, which is 55 times 10 to the minus 3 kilograms of solvent, doing the transformation directly. So the molality for this solution would be 13 over 85 over 55x to the minus 3, which is 2.78075. So after doing the operation of delta TF, which is minus 2 times 1.86 times 2.78, we're going to get 10.34 minus 10.34 degrees Celsius. And since delta TF is going to be equal to temperature minus the freezing point, then the new temperature for the solution would be, as the freezing point of water is 0 degrees Celsius, would be directly minus 10.34 degrees Celsius. So your answer would be minus 10.34. Next up, which of the four colligative properties is based on a system where there is an equilibrium between liquid solution phase and the second liquid solution phase? And the answer to this is going to be the osmotic pressure, which is going to relate the abundance that we're going to have of solids on both sides of the phases, phase 1 and phase 2. And finally, what happens with sodium chloride is added to water. In this case, when we are going to add sodium chloride to water, what we're going to observe are the colligative properties. So at the pressure of the freezing point, that is going to be true. We're going to have boiling point elevation. So boiling point is not going to be correct. We're going to have a lowering of the vapor pressure, which is also a colligative property. And the vapor pressure thus is not going to increase. So in this case, what is going to be the correct answer is 1 and 2. And with that, it would be all. Thanks and have a good one.